Let's take a look at functions and their inverses. So first, let's start off with a definition of a function. A function is when every x value has one y value. So each x has one y. And what you could do on a graph is you could use the vertical line test. The vertical line test will tell us, with every vertical line, that there's only one y value. Here's an example. Here's an ordered set, different points. Is this a function? So does every x have one y? When I plug in 1, I get a 5. When I plug in -1, I get a 7. It looks like every x has its own y. So the answer to this would be yes. Each x value has one y value. One y value. So that would be considered a function. Now when it says find the inverse, what that means is switch x and y. You're going to switch the x and y. Find the inverse of the set. So what I'll do is draw the set notations. Here's the set of all the points. The first point, instead of 2, 5, becomes the point 5, 2. You just switch the x and y. This is going to become 5, 1. This is going to become 7, -1. Oops. And this becomes 0, 0. So you switch each x and y. Now, is this a function? I'm noticing a problem right here. First, you plug in a 5 and you get a 2. But then you plug in a 5, you get a 1. This is not a function. Okay? How do you find the inverse of a function algebraically if they give us an equation? Okay, there's a couple of steps. Step 1, you're going to switch x and y. Just like we just did there with the numbers, you can do it with letters too. And then step 2 would be to solve for y. So then you're going to get y equals form. Okay? And I have to put a note here because you must use the correct notation. The notation for inverse has to be stated when you find an inverse. Let me show you some examples right here. Okay? Let's find the inverse of this. So the first thing I'm going to do, step 1. Okay, here comes inverse. Let's just label our work. Here comes inverse. This says y equals 2x plus 3. So I'm going to say x equals 2y plus 3. Step 1, I switch the x and y. Step 2, we're going to solve for y. I got to get the y alone. So I think I'll subtract the 3 to the other side. Say 2y. Let's divide them all by a 2. So y equals 1/2 x minus 3/2. Okay? But it said you have to use the correct notation. So how do you write an inverse? I can't call it f of x, so we'll say f inverse of x. It kind of looks like a -1 exponent, but you don't say that. What you say is f inverse of x. And that's 1/2 x minus 3/2. So that is the inverse. They want us to graph the original function and the inverse. So maybe I'll color code here. I'm going to graph the original f of x in green, and then I'll graph the inverse in my purple marker there. So how do you graph a line? First you go to the y-intercept of 3, 1, 2, 3, and the slope is 2, up 2 over 1, up 2 over 1, down 2, left 1, down 2, left 1. I want to make sure that my line is really nice and straight and in the correct spot. So I'm going to put as many points as I can on the graph paper. I'm going to use a ruler or grab your ID to make sure your line comes out nice and straight. And I'm going to make sure I label this. This line right here was the original one. I'm going to call that f of x. Now, the next one is the inverse. The y-intercept is negative 1.5. Negative 1.5 is right here. And then a slope of 1/2. So up box brings you to the middle and then over 2. Up 1 over 2. Up 1 over 2. Just make sure you stay in all the middle of the boxes. Down 1 over 2. They're going to crisscross right there. Okay, so this line also has a positive slope, just not as steep. Make sure you get the points nicely. So this is the inverse. Let's label that F inverse of x. So we've got our f of x, and we have our inverse of x. Is the inverse also a function? Is the inverse a function? So take a look at that purple line and perform a vertical line test on it, and the answer is yes. Yes, that inverse is a function. There's another line I want you to draw here. And that would be the line that goes right through the origin, negative 10, positive 10, the line y equals x. This line right here, y equals x, is a line of symmetry. If you were to fold your paper along that line, the inverse function would match up exactly with the regular function. That is a line of symmetry right there. They match up right along that line. Okay, here's just a little box of notes. The notation for inverse, real easy. F inverse of x. Make sure you use that when you're doing your work. You can't call the new equation f of x. Okay, let's take a look at some inverses perhaps in our calculator. Okay, so they're telling us these are inverses. This is x cubed, and this is the cubed root of x. Okay, and so what I want you to do is use a window of -5 to 5, and the y scale -3 all the way up to 3. Okay, so that's how zoomed in I want you to get. So let's go to our y equals, get rid of anything that's in there. And the first one is x cubed. And the second one is the cubed root, which you have to push math. And there it is. Number 5 is the cubed root. I'm sorry, number 4 is the cubed root. 5 could be any root that you want. So I will do the cubed root of x. Okay, and I'm going to change my window right away. -5 to 5, -3 to 3. Okay, did you know that when you push the graph button, if you hit enter, it stops it? It's paused. If you see a little running cursor like that, that means that you stopped it. The graph is waiting for you. Your calculator is not broken. So I'm going to graph this one. Right here, I can see it. This is f of x. And that's x cubed. Okay, I'm going to hit enter again, let it finish. And here comes the inverse. In fact, you could stop it if you want. I'm going to graph the inverse now. And it's going like this. And then it looks like it's coming and crossing over there like that. This is f inverse of x. Let's have it keep finishing. And you know what would be really nice perhaps to see on our calculator? Is that other special line, y equals x. That line should slice right through them if these are indeed inverses. Look at that. Here's the line. Here's the line y equals x. In fact, you could even make that a solid line if you want. Make that a solid line. So if you have inverses, then you're going to have a line y equals x that is a line of symmetry. Okay, so let's officially notice this. What do you notice? F of x and f inverse, those two graphs, are reflections of each other. Are reflections of each other over a special line. Over the line y equals x. Okay, f of x and f inverse. They are reflections of each other over the line y equals x. I could give you a graph and ask you to find the inverse. Okay, and I think the best way to do this, since we have the coordinates right there, is to switch x and y. So what I'll do to find an inverse, remember, is switch the x and the y. So this point right here, 1, 2, 3, 4, 5, 2. 5, 2, if I switch it, becomes 2, 5. 2, 1, 2, 3, 4, 5, right here. Let's find another point. Here's a point. Negative 3, 0 is going to become 0, negative 3. So that point, 1, 2, 3, would be right here. And here's the last point, negative 5, negative 2. If I switch those x and y values, it would be negative 2, negative 5. And then you have that point right here. So I'm going to draw this graph now. Maybe I'll use a ruler. So if I connect these points right here, and then these points right here, and they were so nice to even draw us the line y equals x. Okay, so 5, 2 becomes the point 2, 5. And that's a great way to graph an inverse, okay, very accurately. And you can even fold along the line just to make sure it does work. A lot easier than eyeballing it. Okay, let's do a couple more. We have to find an inverse. To go back to the first page of notes, to find an inverse, I'm just going to write the steps over here, I think. Okay, step 1, you switch x and y. Okay, I kind of want to see these notes when you come to class. These are very important, and this is the question everyone always gets wrong. So let's make sure we're doing it right. This is the y spot, so I'll make that be x equals 2y plus 1 over y minus 1. Okay, step 1 is usually pretty good. Switching x and y, people do not have a problem with that. Okay, now I have to solve for y. Solve for y. How am I going to do that? Solve for y. I can take x and I can put it over a 1. Maybe people want to shout out 2 words. 2 words. To solve this, it would be a good idea to cross multiply. Cross multiply. So 2y plus 1 times a 1 is just 2y plus 1. Then put your equal sign. Now when you cross this way, don't forget to distribute the x. X, y, minus x. Okay, that looks good. Now I was trying to solve for y here. And, well, there's y's on the left, there's y's on the right, there's y's all over the place. Maybe we should put the y's on one side. Which side should I put them on? I'll put them on the left. 2y, switch sides, minus xy. And I'm going to put that 1 on the other side. Negative 1 minus x. Okay, well, at least they're all on one side. I'm trying to solve for y, and I'm having a really hard time doing this. Let's put a star by this next step. This is where people usually get stuck. And when in doubt, factor it out. What are we going to factor out? We're going to factor a y. Factor out a y. Okay, let's see. They both have a y. If I factor out a y, well, at least I only have one y now. But how is that supposed to help me say y equals? Oh, if I divide both sides by that quantity, 2 minus x, that makes y equals. We've got negative 1 minus x over 2 minus x. Except we don't want to write a y. Remember, this was the inverse. So we want to make sure we use the correct notation. People are telling me they keep making silly mistakes and losing 1 point. This would be something right here. You would lose a little tiny point, and they do add up. So let's pay attention to detail and write things the correct way. All right, in order to graph this, let's graph the original f of x, and then we'll graph the inverse of x. And I'm also going to graph the line y equals x. I'll just do that right now on my graph paper so that I can see if they are inverses. This is the line y equals x. All right, let's use our graphing calculator here. And to graph the first one, clear that one out. Maybe I'll use that new fraction key, alpha y equals, and the numerator is 2x plus 1, and the denominator is x minus 1. Let's see, what does the graph look like with our old window? It's kind of weird. I think we should just zoom standard. There's part of it, and there's part of it. And there's the line going right through the middle. Okay, let me tell you a couple things. When you go to graph this, the original f of x is not going to touch 1. So it's going to get closer and closer and closer to 1 right here. And then it's going to go down, 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 like that. And this one's going to come up this way and go over like that. So that is the first one. Now it's time to add the inverse. So into y2, I'll do another fraction. And we're going to get, where is it? Right down here. Negative 1 minus x over 2 minus x. Okay, let's graph that one. Maybe I'll pause it because it's getting kind of weird here. Okay, so this first graph was f of x. And I paused it because I saw some of it going like this, crisscrossing right there. So we've got part of it going like this. And the other part was coming down right here. Let's unpause it and keep playing the movie, see what happens. Oh, and it crosses through and goes down there. And this orange one is f inverse of x. And when you look at all of it at once, it's very messy. There's a lot of lines going on. Color coding does help, but they do reflect over each other. Okay. The last thing that we're going to do with inverses is verify inverses. And let me just talk to you real quick about the word verify. Verify means to show it is true. So please do not take this next test when it says verify and then say it's not true, because you're guaranteed to get it wrong. Verify means how you show it is true. So if they are inverses of each other, something really cool happens. If you compose f of f inverse of x, do all the calculations, you'll get just an x. And this one has to happen as well. Then you put f of x into f inverse. You put them into each other, and both of the answers have to equal x. And if they are, then they're inverses. Okay? So the first thing I'm going to have you guys do is put a little squiggle down the center of your work, because you have to do 2 calculations. In order to verify, we need to do f of f inverse, okay, on this side. And over here, we have to do f inverse of f of x. And that's how you show they are inverses. This doesn't say find the inverse. It says show that they are. And this is the work that you need to see. Make sure you show all of the work. Okay, remember how to compose? F of, and you put an inverse in there. So instead of the letters f inverse of x, let's put this cubed root of x plus 8. And that function has to go into f. And what does f say? F says cube your input and subtract an 8. He says cube your input, and subtract an 8. And our input is a cubed root of x plus 8. Okay, now you have to show me the correct order of things. The first thing that does not happen is I see a bunch of 8s. No, no, no. Order of operations says exponents has to go first. The cube cancels with the cubed root, leaving us with x plus 8 minus 8. And at this point, you can cancel the 8s, and yes, you get x. Surprise, surprise, we got an x. Okay, we all know what the answer is going to be. You just have to show me how you're going to get it. Okay, on this side, we have to calculate f inverse of f of x. And f of x is x cubed minus 8. Okay, what does f inverse say? F inverse says take the cubed root of your input plus 8. He says take a huge cubed root. Let me draw a huge cubed root. Your input plus 8. Input plus 8. Okay, so here's me getting ready. Input plus 8. And the input is x cubed minus 8. All right, what's going to happen first? This entire thing is not being cubed, so you cannot cancel those just yet. Plus and minus 8, those can get canceled first. Order of operations, you can do adding. And then we have the cubed root of something cubed, which does cancel, and give us just an x. Okay? So we all know what the answer is going to be. The points are going to be in showing the step line by line. Don't forget to write equal signs, and don't forget to write what you're calculating. You have to tell me which side is f of f inverse and which one's f inverse of f. All right, let's do another one. First things first, separate your paper into two for two calculations. On this side, we're going to do f of f inverse of x. And then over here, we'll do f inverse of f of x. Okay, so let's do the left-hand side. The first thing we're going to do is put the inverse in those parentheses. 1 over x plus 1. Okay, and that has to go into f. Let's go see what f says. F says 1 divided by input minus 1. Let's get ready for that. 1 divided by input minus 1. And the input is 1 over x plus 1. Do these parentheses really do anything down here? There's no distributing. It's something plus something minus something. So those parentheses really don't mean anything. You can just get rid of them. Plus 1 minus 1 would be the first thing to cancel. 1 divided by 1 over x. I think I might go old school here. I might go old school. Instead of this divide, I'll do 1 divided by 1 over x, which is 1 times the reciprocal, which is just an x. Okay, make sure you legally show line by line how to get there. Over here on this side, we're going to do the inverse of f of x, and f of x is the fraction 1 over x minus 1. Okay, that input has to go into f inverse. F inverse says 1 divided by input plus 1. 1 divided by input plus 1. And our input is 1 over x minus 1. Here's that quadruple decker again. I think I'm going to go old school and say 1. Instead of divide, I'll say divide by 1 over x minus 1. Don't forget to write this plus 1. I'm going to take care of that in just a second. Then we're going to flip this. 1 times the reciprocal. Don't you agree? It's just going to be that. You don't really need to say times 1, do we? Plus 1, cancel, cancel, and we get an x. So we had a lot of information. Nothing too hard. It kind of uses a lot of the skills that we learned so far this chapter. Can you algebraically find an inverse? Okay, and you switch x and y. Okay, and don't forget the correct notation. F inverse of x. Can you show the reflections of each other, reflections of each other over the line? So draw two graphs and then draw that line. Can you algebraically verify their inverses by doing what we just did, two calculations? This chapter is getting close to the end.